We have first exercise, exercise 1.1. Now the first question is use Euclid's division algorithm to find SCF of the given number, and the first one is 135 and 225. We have to find the SCF of numbers 135 and 225. First compare these two numbers 135 and 225. Between these two numbers 225 is greater than 135. Then by using the Euclid's division algorithm, we have the first step. As we know, the Euclid's division algorithm is A is equal to BQ plus R. Then here the number A is 225. Then 225 is equal to divisor is 135. Then after dividing 225 by 135, we have the quotient is 1. 135 ones are 1, 135. Then subtract 135 from 235, 225, then we have the remainder is 90. Okay, here the remainder is not 0, means we have to continue the next step. Then in the next step we'll have two numbers are 135 and 90. Between these two numbers we'll have now 135 equal to divide 135 by 90. Then after dividing we have the same quotient 1. Then subtract 135 from 90. Then we have the quotient is 45. Here also we have the remainder is not 0. Then the next step is 90 is equal to divide 90 by 45. Then the quotient is 2 and the remainder is 0. In this step we get the remainder is 0. Then the here in this step the divisor is 45. Then the SCF of given two numbers 225 and 135 is 45. Okay, then you can solve the next two examples given in the textbook same like this. Then we have question number 2. The question is show that any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Then here we have to prove this theoretically. Means we don't know the numbers. We have to consider the numbers, the positive numbers, whatever be the positive numbers, that number should be in the form of odd numbers are in the form of 6q plus 1, 6q plus 3, 6q plus 5. Then here we have to consider, here the form of the number it is given, Euclid's division algorithm, that form is given. It is 6q plus 1. Means if we have to consider one number a be any positive integers, then we have the equation a is equal to 6q plus 1. Okay, means this one is the 1 is the value of b. Okay, because we have the equation a is equal to bq plus r. Means if we consider a, whatever be the number a, but here the form is given 6q plus 1, then the value of b becomes 6. Okay, means a be any positive integer and value of b is 6, b equal to 6. Then here we have to use the Euclid's division algorithm. We know the Euclid's division algorithm a is equal to bq plus r. But here the form is given 6q plus 1. Then the general form it becomes a is equal to 6q plus r. And here the condition for remainder. The condition is r should be greater than 0, greater than or equal to 0 or less than 6. Because why it comes 6? Because the value of b is 6. If the value of b is 4, 3, 2, you can take the same value here. Okay, then here we have the conditions for r is, it is less than 6, it is 0 or greater than 0 and less than 6. Means the value of r are 0, 1, 2, 3, 4 and 5. Less than 6 means it is 5, not less than or equal to 6. Means we have to take the values from 0 to 5 only. And here we have to prove that the positive odd integer in the form 6q plus 1 or 6q plus 3. Means here you can put the 1 value of r. First of all, in this equation a is equal to 6q plus r. Put r is equal to 0, then we'll get 6q plus 0 means the equation is a is equal to 6q. Then after taking r is equal to 1, a is equal to 6q plus r means 1. Then taking 2, a is equal to 6q plus 2. By taking value of r is 3, a is equal to 6q plus 3. R is equal to 4, then we'll get a is equal to 6q plus 4. R is equal to 5, a is equal to 6q plus 5. But we have to prove that only odd values. Then between these all that values, you can take only odd values. Odd values, which are the odd values? We know the odd numbers 1, 3, 5, 7, 9 like that. Then here the odd numbers are here when r is 1. The first equation is 6q plus 1. I mean, by taking R is 3, 6 cube plus 3, and R is 5, 6 cube plus 5. That means we'll get the answer for odd integers. It is in the form of 6 cube plus 1, 6 cube plus 3, and 6 cube plus 4.